What is the NAO Index? Have you ever wondered how weather patterns in the polar regions are influenced by atmospheric pressure? One key factor in this is the North Atlantic Oscillation Index. This index measures the difference in atmospheric surface pressure between two important areas in the North Atlantic, the Subtropical High near the Azores and the Subpolar Low near Iceland. This pressure difference creates a pattern that significantly affects weather and climate across the North Atlantic, including the polar regions. The North Atlantic Oscillation Index fluctuates around zero and has two main phases. In the positive phase, there is a stronger pressure difference. This means lower than average pressure over the polar North Atlantic, which includes areas near Iceland and Greenland. At the same time, there is higher than average pressure over the subtropical Atlantic near the Azores. This phase strengthens the westerly winds and the North Atlantic jet stream. As a result, northern Europe and the eastern United States often experience warmer and wetter conditions. Meanwhile, Greenland and parts of the Arctic may see colder and drier weather. On the other hand, during the negative phase of the North Atlantic Oscillation, the pressure difference weakens or reverses. This leads to weaker westerly winds and a shift in storm tracks. In this phase, northern Europe and the eastern United States can experience colder and drier conditions, while Greenland and parts of the Arctic may warm up. For the polar regions, the North Atlantic Oscillation Index plays a vital role in shaping atmospheric circulation patterns. These patterns affect temperature, precipitation, and sea ice conditions in the Arctic and subarctic. For instance, a strong positive phase can lead to colder air masses over Greenland and nearby Arctic areas. This can influence ice sheet dynamics and local climate. Conversely, a negative phase can bring warmer air into these regions, impacting ice melt and atmospheric conditions. Additionally, the North Atlantic Oscillation Index affects the intensity and path of storms crossing the North Atlantic. This can influence sea ice distribution and ocean circulation patterns connected to the polar environment. The variability of the index occurs on timescales from interseasonal to interannual. This means shifts in the North Atlantic Oscillation can lead to extended periods of distinct weather patterns in the polar North Atlantic and surrounding areas. In essence, the North Atlantic Oscillation Index is an important atmospheric climate indicator. It measures pressure differences between the Azores and Iceland, shaping weather and climate across the North Atlantic and polar regions. By controlling wind patterns, temperature, and precipitation, its phases have direct effects on polar climate variability, sea ice conditions, and broader Arctic environmental processes.